Hello, and welcome to the AI Research Roundup. I am Alex, your host. Today is May 22nd, 2025. We are diving into a fascinating research paper from Hugging Face's trending list, published just yesterday, titled WebShepherd, Advancing PRMs for Reinforcing Web Agents. This paper, it addresses the tricky problem of teaching AI agents to navigate complex websites. It introduces WebShepherd, a novel approach using what is called a process reward model, or PRM. A process reward model basically evaluates an AI's actions step by step, often using checklists to track progress, rather than just looking at the final outcome, which is key for these long web tasks. Alright, so this first figure really highlights the performance and cost efficiency of WebShepherd. On the left, we see bar charts comparing models on WebRewardBench. That is a new benchmark for evaluating these process reward models, specifically for web navigation tasks. WebShepherd, in orange, clearly outperforms others in both mean reciprocal rank, or MRR, which measures how well it ranks the best next action, and in step level and trajectory accuracy. Then, the plot on the right dramatically shows its cost effectiveness, placing WebShepherd high on performance, but very low on cost compared to models like GPT-4o. Okay, so to achieve that impressive performance and cost efficiency, a really robust dataset is needed. This next figure, it details how the authors built their core dataset, the WebPRM Collection. At the top, we see human annotators working with many real websites to create tasks. They record optimal action sequences, and also rejected ones, crucially using checklists to break tasks down. The bottom then shows an example, like finding warranty info, with the checklist guiding feedback on actions. This granular step-by-step data is really what powers WebShepherd's precise reward system. Building on that dataset creation, this figure provides a great overview of how WebShepherd actually works and its applications. On the left, it shows the two main steps. First, a user instruction is used to generate that crucial checklist. Then, this checklist guides the rewarding process, evaluating an agent's actions and assigning a reward based on the probability of checklist items being yes, in progress, or no. The right side then illustrates diverse uses, like guiding an agent search, refining actions, or in a reinforcement learning, or RL, loop. Reinforcement learning is a method where an agent learns by trial and error, using these rewards to improve. Okay. So this table lays out the evaluation results on WebRewardBench. We see models compared on mean reciprocal rank and trajectory accuracy, which is how correctly they assess an entire sequence of web actions. Across various challenging test conditions, WebShepherd, especially its 8B version with checklists, posts dramatically higher scores, often best with just text inputs. For instance, on Web Arena, it achieves nearly 98 mean reciprocal rank and 85% trajectory accuracy, far ahead of GPT-4o. This highlights the checklist's effectiveness, and also that multimodal inputs are not always superior. Okay, so those WebRewardBench results were impressive. Now, how does this improved reward modeling impact actual task completion and efficiency? Well, this table shows success rates for trajectory search on Web Arena Lite. Trajectory search, that is the AI exploring action sequences to find a successful one. When GPT-4o Mini is the policy, the AI making web decisions, and WebShepherd 8B with its checklist verifies the path, success hits 34.55%. That is a nearly 11-point boost, achieved much more cost-effectively than using larger models as verifiers, highlighting WebShepherd's practical value. Speaking of that practical value and cost, this table really drives the point home. It shows the cost in US dollars per 1,000 instances for different models. And look at this, WebShepherd 3B comes in at just $4.67. Compare that to GPT-4o at over $435, or even GPT-4o Mini at over $43. This stark difference underscores WebShepherd's massive cost advantage for web navigation tasks, making it a much more scalable solution. So, considering that incredible cost efficiency we just saw, it is clear WebShepherd marks a significant advance. It introduces a specialized process reward model, or PRM. A process reward model is an AI system specifically designed to evaluate the process of completing a task, step by step, rather than only the final outcome, which is crucial for complex web navigation. This leads to higher accuracy and better task success, at a fraction of the cost. It truly paves the way for more robust autonomous web agents. That is all for this AI Research Roundup. I am Alex. Thanks for listening.